Hello, bonjour and welcome to the Don't Waste Water podcast. I'm your host, Antoine Walter, and I have the great pleasure to welcome again Ravid LEVY as my guest today. Ravid still is the CEO and founder of RLV-consulting, and you might have heard him in episode 2 of this podcast, guiding us through the steps of innovation in water and wastewater treatment from idea to commercial success. In today's episode, Ravid dives into the opportunities, trends and risks of pre-assembled and often containerized treatment solutions, highlighting the sweet spots but also the pitfalls. He discusses commissioning of such plants and eventually takes us to Antarctica. But let's avoid spoiling too much.
You're listening to Don't Waste Water, the podcast that helps water professionals to improve their wastewater treatment, optimize their operation costs, and keep up with the latest market trends. This podcast is brought to you by GF Piping Systems. As a leading supplier of piping systems made of plastics and metal, GF Piping Systems is the global expert for the safe and reliable transportation of water, chemicals, and gas. For more information, visit gfps.com.
Hi Ravid, welcome back to the podcast. Last time you walked us through the steps of a successful innovation, from the original gap that generates an idea, and then finally that leads to the go-to market through maybe IP protection or prototyping. But towards the end of the interview last time, you addressed a key point, and that is going to be our main topic today: standardization. That sounds somehow like the dream, especially in industrial water and wastewater treatment, a handful of standard Lego bricks, if I may say so, that could be assembled on every site in order to build a plug-and-play solution. That sounds nice, and we're going to see in the next minutes if that's real or if we might have to do a reality check on that. But maybe just before digging into that dream between brackets, let's start with this reality check. Do you see plug-and-play solutions as a trend on the water and wastewater market?
So first of all, if still to connect to the previous topic, some actually may say that putting things in boxes or in building blocks is the opposite of innovation. So you actually need to standardize, and then there's not too much room to go wild. It's a packaging exercise. So yes, it is in a way a packaging exercise. Actually, the limited size and the need to make things more efficiently in many different aspects require a lot of innovation, both in design, engineering, but also in technology to make things smaller, more standard, if you like, or easier to install and operate. That takes a lot of innovation, maybe not always new inventions, but a lot of thinking differently about things that we used to do forever in this industry. Yeah, I think that standardization in general and containerized solutions particularly is a trend in the industry. I think it's more a trend than a fashion. So there is actually a market and activity in that range. However, it's not a magic bullet. It does not, and it will never give a one-size-fits-all or a standard answer to all water and wastewater challenges. There are areas and cases where it is almost ideal or the perfect solution to a problem. In other cases, it can actually bring more limitations and more disadvantages than advantages. And maybe later we will discuss some examples of where are those sweet spots and where are the pitfalls for that approach.
Before digging into that, maybe you can explain us, in your view, what is setting the trend? Why are we trying to get it standard, to put it in containers? Why?
So few vectors maybe in the market, I think sets this trend. Maybe the most important one, which is kind of a buzzword that is used a lot lately in the water industry, is decentralized solutions. So moving or realizing that the large-scale centralized plants that always were and probably always will be the majority of the capacity of treatment, especially in in big urban centers or highly populated areas, they are not the best economic, environmental, or operational solution for where population is spread around a large area in smaller settlements or smaller towns or villages or whatever those non-urban centers are. And in those cases, and actually some people even take it further to say that even in urban centers, it is more efficient to treat wastewater and water on a local basis. Microgrids, renewable energy issues are involved here, sometimes under the microgrid approach of supplying energy and water locally rather than transferring them over large distances. This trend of decentralization of water and wastewater facilities naturally pushes towards smaller units, more localized, and therefore lends itself to more compact and more standardized building blocks, if not full system. So this is the main trend, I think, at the moment, especially on the municipal side of the business. On the non-municipal side of the business, that may be industrial water, remote operations, whatever that may be, this is more mobility and site and minimization of site works. The industry, the companies, and the clients realize that having people on site is expensive, difficult, risky sometimes in some places. So minimizing that interface at site is another trend that leads towards pre-assembly of units. And once you pre-assemble off-site, there's a necessity to package it somehow for transportation or just for easy installation on site as a more complete unit rather than components. So rather than bringing endless boxes of valves and pipes and instruments and cables and everything to site, a lot is being pre-assembled into complete or partially built units off-site. And then that leads to more skid installation or containerized design that allows also the shipping and the enclosure, building, if you like, to be replaced off-site.
So decentralized treatment, which is mostly the trend for municipal projects, and then on the industrial side, more this aspect of avoiding to have to work on site and do prefabrication. In that second case, would you say that the trend might have been learned by the industry the hard way because they had difficulties with the on-site? So maybe you can elaborate a bit on that. I would be interested.
Yes, one of the pain points of the industry is site installation work and subcontractors working at remote locations. All those things, I think every company in the business have their their stories for those past projects that went bad or just were difficult or more expensive than expected because of that things went wrong or just actually as expected, but not as hoped, or the best case scenario was not realized, which, by the way, is the usual case. That's why it's called best case scenario. But in some cases, all those complications are not fully factored, and they create a problem. Now, when the project is massive, on one hand, there's no much alternative. You have to do civil works and large installations on site, and then this is the majority of the project actually. But when it's a small scale project, also in terms of money involved, then the risks and the costs that are involved with things getting complicated on site are too high, and the margins in this industry are unfortunately sometimes not huge, especially for the integrators who's eventually taking responsibility, the EPCs that takes responsibility for the delivery of the project, including the site work. So minimizing that and maximizing off-site pre-installation is obviously very good for the bottom line and for reducing risks.
It's minimizing the exposure and managing the liability somehow.
The liability, the risk, and the direct cost. Labor back home is usually less expensive than people working at remote sites or just overseas or wherever that may be. And if you add to that risk issues like safety, and other considerations like in mining sites, oil and gas operations, power plants, industrial locations, where just having people on site going back and forth for a long time is a problem, both for client and for the one responsible for delivering the project. Altogether, that brings, it's like, bring the work back home as much as possible.
Would that somehow define a kind of sweet spot? You mentioned that large projects are not that easy to prefabricate, but smaller ones sound like a sweet spot. And then, as you said, if it's just the next door, then maybe you don't need, but if it's still the end of the word, then it might be written by itself that you have to pre-build something. What do you think there?
So first of all, I think it's worth differentiating between two types of offsite or prefabricated plants. Mm-hmm. Some people confuse them. Every time we talk about prefabrication, the next word is standardization. But this is not necessarily the case. This is actually a later trend because package systems, containerized systems, skid-mounted systems were there for many years. I've worked for companies that specialized in that, 20 years ago. But every plant was still very different. So they were tailored, but packaged off-site. This is very common for industrial power, mining, other cases where despite the motivation to standardize, the process, the unique water or the client specs dictate a different system every time. However, there is still huge advantage in prefabricating and packaging the plant and minimizing site works and everything we discussed. The advantages of reduced site works and cost and risks and all that still exist even if the plant is not standardized. If you add to that the ability sometimes to have standard building blocks, that takes it to the next level of also reducing the cost of equipment and the design risks and the need to do all the HAZOPs and some of those design reviews and engineering resources every time for a different system. So this is a first separation internally inside this package plant market. Both have markets, both have sweet spots. So I think that in general, the smaller, the more remote, and or the more decentralized the application is. Obviously, this is a sweeter spot for any of those. Some industries, they've been working with this kind of approach for a long time, especially the mining industry, which naturally works very remotely in some cases. The power industry with containerized or packaged systems for expanding or for just installing quickly water treatment capacity with minimal site works and footprint. Footprint is a very important issue here because some of those plants naturally tend to be very compact. So when real estate in general is footprint is expensive or very limited, obviously a very important sweet spot. That may be anywhere from offshore oil and gas rigs to power plants or to factories, especially in cases of upgrades or capacity increase or retrofits or all those things that have to somehow fit on existing sites. That's on the industrial side. Another very, very important market in some places, some countries for these solutions is the rental market or temporary solutions, because that obviously allows a complete unit to be delivered to site, operate as much as needed, and then taken off-site with minimal disruptions or works, both on the installation and also the decommissioning parts of the project. And that's a big advantage. And the mobility, naturally, is a very important thing. Companies that export plants, they even take it further because the marine freight naturally works around packages like containers and those kind of boxes. And if you can design your solution inside one of those boxes, then it can be taken on the ship, off the ship, and to site very easily and with minimal cost.
You've been addressing the cost now. We've listed the advantages of the package, the containerized solution, and The first seem to be technical, but if we come to cost, let's be really to the bottom of it. Do you expect savings?
In fact, there are many or some technical disadvantages, which we may talk about a little bit later. I mean,
let's keep the pink glasses for now. Let's be optimistic. So.
Yes. No, I'm not. It's not a problem as long as you're aware of it and handle it properly during the design of the system. But it's not a magic solution that has only positive aspects. But on the cost side, there are some risks or some possible issues just because of the need to work with very compact equipment. So you are less free to choose from the market components if they take too much space, for example. They may be better technically or even cheaper, but you would prefer a more compact component because space, real estate in those, especially containerized cases, is the prime resource. There are so many things that can be done with every square foot of a container floor space or even a wall or volume that need to choose very wisely. This may sometimes come on the expense of some cost. So this is to begin with. However, there are serious potential cost savings, especially, as I said before, shifting more of the work to offsite or to the factory rather than to site. And also, if shipping is involved, there's serious shipping costs that can be saved if the packaging is suitable for sea or ground freight, for that matter, in some other cases. So there are cost saving that can be realized here, and there's also a lot of risk, and risk should be a cost item in every project.
I think that's something that you've been teasing now, so I'm going to quote you because I love that. We always talk about plug and play, and you said beware, because that might be also plug and pray, which is just kind of summarizing the risk that might be implied when going to those kind of solutions. So I would be really interesting to know what you see behind that. So what's the risk? What are the pitfalls behind the containerized or standardized or prefabricated solutions?
So there are some pitfalls generally in containerized approach or in the assumption that if I do a lot off-site, then on-site will be a piece of cake and there's nothing to do there. The fact that more of the work is shifted to the factory does not mean that there are no operational risks and startup issues and other things. Obviously, they can be reduced in some aspects, especially the technical, the mechanical aspect. The factory test can be much more complete, and you can make sure in advance that there are no leaks or control or electrical or other issues. But the process at the end needs to work on site, and this can only happen when the actual water or wastewater are flowing through the system. So assuming that the fact that this is prefabricated, and then, all right, let's send someone over, doesn't matter who, we've tested the plan. What can go wrong is taking this a little bit too far. We always need to remember that at the end, it's not really a plug and play. This is plug, commission, operate, deliver to client. And the plug side becomes very easy when it's prefabricated. But the other aspects are at least as complicated or as risky as they would have been in any other plan. So it's not really plug and pray, but plug and don't tell yourself the story that everything will just tick from this point as if it's a TV set or a food processor. This is not the case.
Do you think that people underestimate that aspect?
Yes, a lot, because I think that in many organizations or many cases, once the decision is taken to standardize the system, it is being regarded from that point as an engineering exercise, and the engineers take over. I think it refers a little bit to our previous discussion last time. The there's always this kind of tension between the mechanical or the engineering part of things and the process and then also the commercial side of business. And once the standardization project begins, it is regarded, and there's a lot of design, mechanical, electrical, and other design issues that can be integrated and then can be tested offsite. But then the process, whatever is left to be done on site, is almost taken sometimes too lightly, as if it's trivial if we tested the plant at the factory. There are lower risks on all the mechanical, electrical control aspects, but the process must still be taken seriously, because at the end, this is what we deliver. We deliver a machine, in most cases, that should treat water to the specs or to the requirements it was designed for. The fact that it works mechanically and electrically is a prerequisite, but it's not enough.
Did you experience that yourself? Did you have bad experience with the commissioning of plug-and-play solutions? Something you can talk about, of course.
There are several cases, both good or better and less brilliant, where, for example, a power plant in South America that we've supplied a ultra-pure water system for once. And everything was pre-assembled in containers or skids, or it was a combined design and delivered to site, and everything was ready there. There was minimal civil works and everything. The installation went very, very well and quickly. But then the water quality at the feed was different in some ways than what was expected according to the information we had. And the commissioning phase on site at a very remote place in South America took much longer than we expected. Obviously, or maybe unfortunately, the budget for the project assumed that the commissioning would go as quickly as installation, because it's prefabricated and factory tested. And once the commissioning people and the process engineers had to extend the stay and do more runs and more lab tests and other adjustments, the financial people started to get stressed about that, because it was not expected. I think everyone who supplied those kind of systems have those examples. Still, if that project would have been done as a non-prefabricated or a non-containerized with a lot of civil infrastructure and on-site installation, it would still be much more expensive and complicated than how it ended. But at that point, it's not anymore the comparison. You already have this, and you already designed it, budgeted, and scheduled it as if it's packaged. Although most of those examples does not reduce the advantage of that solution against the conventional or the alternative, but the risks must be acknowledged even within that approach.
If we try to compare, I don't know if the comparison makes sense, but I'm wondering now, in terms of agility between a traditional construction with civil works and everything and the package solution, you know that there's this saying that water decides at the end of the day. So one would imagine that if you do everything non-standard and customized, and then you have exactly what you said, a different quality of water than the one you expected, with the superior agility of the civil works specialized solution that you build on site, you would be able to handle that. Whereas with a prefabricated solution, you might be limited by the design of what you have. Does that make sense, or can you reach the same agility with both types of systems?
In theory, there shouldn't be a difference, because if you design a flexible system in advance, it will be as flexible with or without a container. However, the limitations, the engineering and other limitations that a package like a container sets lends itself to a more aggressive or a more maybe a less conservative design, and sometimes there are just physical or objective limitations that make it impossible to include too much flexibility. Also, of course, this is in general in terms of packaging things into limited boxes in any type there are some design limitations and compromises that you have to do. Maybe the most important one in any compact or containerized plant is the space and the ability or the ease of maintenance and operation later. So those containers are sometimes the design engineer dream and the O&M technician nightmare. Because naturally, all the need to pack everything as compact as possible reduces the access and the ease of extracting equipment and replacing equipment and fixing leaks or anything. There are always compromises on that end. And this is very important to remember, to leave at least minimal, or to remember that those plants need also to operate somewhere, and operation requires some human intervention. So in design process, it's not always, there must not only be, how much capacity can we squeeze in there and how will that cost to deliver. It's also how later the client or anyone will be able to operate that and maintain that practically. And also if you're a commercial company without, spitting on the ground every time it gets near your system, and just because you never thought of their side of it when you design. This is one aspect always to remember. I've sat in quite a few design reviews for containerized systems, and these are some of the most interesting ones because there are so many limitations that, how can you decide between, the placing the equipment, maintaining it later, the cost, the access, the piping routes, which sometimes, they sometimes defy or at least work borderline on what is being taught on, hydraulic engineering regarding velocities and diameters and I don't know how many diameters before an analyzer or a flow meter and other things. There are serious limitations when you pack things into compact packages.
So you might have to compromise.
So you always have to compromise. It's just a matter of how far you want or you need to take it. So also there's the upper limit of capacities. There's some kind of almost race in the market of how much can you squeeze into a container, how much wastewater treatment or how much desalination capacity. And I think it gets to a point where the compromises are starting to be too high, either on engineering or commercially in terms of promising to client things that are actually very, very hard to achieve.
There might be a roof to the capacity you can reach with containerized solutions in a pleasant way to operate and in a pleasant way to run smoothly.
First of all, without compromising good design, process, and engineering, and then if you add to that a reasonable operational room and access, then yes, practically there is an upper limit for every technology. Of course, you can argue if this is, if it's desalination, would that be 1,000 cubic meters per day or maybe 1,200 or just 800? But we've been designing at the time and even supplying a single container for seawater desalination, including pre-treatment, control, everything for 1,500 cubic meters a day in one container. And that was, to me, quite amazing achievement with somehow a very reasonable operational and maintenance room inside. But to be honest, there were, I think, too many design compromises there in terms of velocities, diameters, and some, squeezing recovery out of membranes and other things. The ability to actually meet that very ambitious capacity was actually limited to a pretty narrow situations. The system was actually not very flexible. That was one of the main compromises for squeezing more equipment and pushing it to the upper limit of pumps and membranes and other things.
There might be a maximum of what you can reach with containerized solutions. But if we look at it the other way around, you've mentioned decentralized as a trend, which is pushing towards containerized solutions. But could we see it also the other way around, saying that the ability to put everything in containers is also pushing for decentralized? Because if you look at industrial sites, there might be several streams. And today you are taking all these streams and bringing them together on a treatment plant, because that's the most convenient way to do it if you have to fabricate everything at one single place. But if now we think that everything might be put in skids or in containers, that could be an opportunity to put a treatment step next to each stream and have, in fact, not one water system, but 5, 6, 7 water systems, very specialized for a single batch process. Do you see that as a possible trend, or would you say, no, that's just too theoretical?
Yeah, in industrial cases where there are different streams that require different treatments, like treatment at the source rather than a mixed stream, that can be a good solution in some cases, especially, again, if space is limited and if they are separated physically from one another. In the municipal decentralized market, which is where the main decentralized trend is, it means that smaller communities can get their own high-end treatment without a major project with civil works and other things every place, and overall lower cost. So deploying many localized, small-scale and prefabricated plants. In fact, for that market, especially the domestic wastewater market, it makes a lot of sense because the feed water, wastewater, is similar in different places or different communities. The capacity might be different, but the composition, unless there is industrial or major agricultural, like animal farms and other things that combine into the sewer, then, our sewer systems are pretty similar in composition in different places. So it can be easier to standardize the process building block and then multiply it to a certain extent as a modular system according to the capacity. However, modularity is, we haven't mentioned this magic word yet, but this is another buzzword in this industry, right next to standardization and prefabrication. Modularity is a very important aspect of this approach. However, it also has risks that must be avoided or at least be acknowledged. The main important one is economy of scale, which almost by definition does not exist with standard building blocks because the cost and the complexity of the system is almost linear. If you have one container or 3 identical containers, the overall cost per unit volume remains almost constant. Above a certain capacity overall, it does not make sense economically to keep expanding on a modular building blocks. It makes much more sense to build one larger system that can realize the economy of scale. For example, in wastewater, building one concrete basin for biological treatment rather than multiple containerized tanks, because each one of them will obviously cost less, but all put together, it makes it easier to and cheaper and more compact even because of the distances between the blocks to build one central volume. The project capacity is a different thing than the unit capacity. And this is again why the smaller the case and the more remote it is, the more logical and economical it gets to use those prefabricated, modular, possibly containerized solutions.
To round off this part, I would like to appeal to your experience. Would you have an example from the projects you've been working on of where you could find a significant edge in containerized or prefabricated solutions over the conventional ones?
Yeah, possibly the most extreme or unusual case was a desalination plant that we built at the time for Cyprus. And that was the largest containerized or modular plant that I know of, which was 22,000 cubic meters per day of seawater desalination, including everything, UF, pretreatment, energy recovery, RO, etc. That required, from memory, something like 30 containers to accomplish all together, including control, electric, everything was containerized there. In a way, this is an extreme case where in most cases it would have been much cheaper and even easier to build the same capacity in one conventional desalination plant. The reason why that specific one was containerized and that there was an advantage to do it this way were two reasons. One, it was very urgent. The process, all the design, construction, and authorizations that were required to build a conventional permanent plant over there would have just been taken too long. And this one was built, delivered, and commissioned within about 6 to 8 months, which is for this capacity amazing in our industry. The other reason why containerized was perfect for that situation was that it was temporary. It was from the beginning a temporary emergency water relief solution that was from the beginning designed to be disassembled and be removed after 2 or 3 years of operation. And in fact, that was the case after, I think, 3 years eventually of providing drinking water over there. Is being disassembled and actually being taken apart and being rebuilt, and now, as far as I understand, is offered as 3 different units of 7,000. So it's been operated as one system of 22 or 21, and now been reconfigured and re-engineered to be, again, an emergency or a temporary containerized plant, but for lower capacity. And this is exactly where containerized can do things that other designs probably cannot.
Yeah, that sounds like a win-win-win. You can go much faster, then you can also deassemble again the day you don't need it anymore. And the things which are deassembled can be just reused because a container still fits on a ship, still fits on a truck, so you can put it somewhere else. And again, use that capacity. So that's, I guess, an interesting example. And I might suspect that might be a spoiler for the rapid fire questions, especially the one on projects. So Ravid, if it's okay for you, I would propose you to move to this last section of the rapid fire questions.
It's time for the rapid fire questions.
As you already were my guest on that podcast, you've answered the standard question first time. So I'm going to give you a second round on the same questions. And then also I prepared you a new set of questions to surprise you. So let's start with the good old ones. And let's see if your answer might differ from the first episode. So what is the most exciting project you've been working on?
By far, I think that was supplying a packaged, skid-mounted, eventually containerized system for desalination of water for the Australian Research Centre in Antarctica. That was a very challenging case, of course, because of the location, because of how remote it is, the need to actually test and do everything in advance. And to make things even more interesting, unfortunately, on the way to Antarctica, there was a huge storm, and the system, after being fully commissioned off-site, was damaged and had to be returned and, in fact, be rebuilt and recommissioned and sent again in the next season. So that was a pretty amazing project that eventually worked. I think until this day, they get good drinking water out of that system in Antarctica.
Well, I think you just beat all the other stories I've heard. I mean,
I know, it's a good one.
Wow. So, what's your favorite part of your current job?
In this case, I would just have to repeat what I said before.
Okay.
It's the flexibility and the variety of technologies, clients, and projects that I have the privilege to work with.
What is the trend to watch on in the water industry?
Specifically, there are many trends, but just not to give the same answer, and also to relate more to our topic today. I think this is the universal ultrafiltration systems and racks that allows the client to not to be married with one type or one supplier of UF membrane along the life of the system, but to select later between different options.
What is the thing you care the most when designing a new project or a new system, and what's the thing you care the less?
So again, in projects, there are many things, but specifically on package or containerized systems, I care a lot, or I highlight a lot the operation and maintenance availability and space, or in general, operability of the system. And also, which goes together very well, safety aspects of operating or, working with that package systems, just so those design compromises will not risk anyone.
And what would you care the less, if there's something?
Yeah, I would have to say equipment brands, because some people really like to have, fancy brands on some equipment, but there's a variety of equipment there, and the selection of specific equipment must really go based on how critical it is and how what is the track record of that specific brand or make, and not necessarily the biggest names out there, which may add to the cost, actually also add value.
Okay, now don't be afraid, you're still under the fire of my questions, but here you have the fresh ones, which no one ever had before you. So what is your favorite part of a project?
My favorite part? I actually love the design reviews, where people from different sides of the project sit together with, or maybe towards the final design reviews, where the project already has a shape and a design aspects have already been included, and now people from different parts of the project or the company sit together and debate the compromises, or actually have to decide, where to pull and push it to finalize the design. And when the engineering, project management, financial process control, other people are kind of putting their minds together to sharpen the pencil.
What is something you are doing today in your job that you will not be doing in 10 years?
Hopefully work. No, I'm joking. I don't actually really want to retire too soon, because I kind of enjoy it. I can say, in every work there are very, less pleasant parts. Maybe after this period of time, I really think that it's time that we will reconsider traveling so much for meetings, and always put the option of saving time and pollution and money on travel, and just sometimes, not always, sometimes communicate remotely.
Now I have one which is interesting, because that reflects something you've mentioned earlier, the difference between trend and fame. So what is the trend or fame in our industry that you would like to see ending and disappearing forever?
As someone who's doing desalination for many years, it's not a trend. It's until now the best practice, but I would really, really wish that the throwing away the brine back to the ocean as is will be replaced by something more sustainable and economical. But of course, this is a huge challenge, and we now desalinate so much water that it's a massive thing to even imagine a different solution to all that brine. But if we're already dreaming, why not dream big?
And last, can you name one thing that you've learned the hard way?
I think maybe that there are no easy ways to learn. I mean, if you learn something any other way, you probably haven't learned it properly. the harder it is, the more efficient the learning is. Another thing, probably, and I say that to my kids a lot, that it takes some time to understand that the most efficient learning is from the experience of others, rather than from your own experience. So if someone already learned something the hard way, and you can now skip some of that and learn this from his experience, then it is a bit easier. But still, you can, if you don't experience things and you don't fail sometimes, then, you haven't tried, I guess.
Or not hard enough.
Not hard enough, correct.
Well, Ravid, you've been an amazing guest, so thanks a lot for that. If people would like to learn from your experience, where can they find you?
I'm available by email, and then finding me online is best on LinkedIn, I guess.
Dear listeners, you know where to go to learn, maybe the hard way, but to learn about the experience of Ravid. And I think there's a lot there that might be helpful to water professionals. So thanks a lot for being my guest now twice. And, I don't know if that translates in all the languages, but in French we say never two without three. So I guess somewhere down the line, we might have a new topic to discuss together.
Well, thank you for inviting me. And I'll be honored to maybe do it the third time. Yeah, I think we have a version of that 2 and 3 thing also in Hebrew.
So thanks a lot, and see you soon.
Thank you. Bye-bye.
Thanks for listening to Don't Waste Water. This podcast was brought to you by GF Piping Systems. Loved this episode? Head over to Apple Podcasts to subscribe, rate, and leave a review. See you next time.